Hello students, welcome to today's session on position and time graph, which is straight from the unit of motion in 1D, motion in one dimension. So this particular topic is actually marking the end of the chapter, and we can very easily see. I would just like to give you a brief of the graphs which we will be considering in this chapter, the various kind of slopes and the magnitude of slopes, how it varies. And in the very first graph, we can see the rectangular hyperbola, it is decreasing, and the magnitude of slope is also decreasing. Certain pinpointed conditions of position with time are these graphs and these captures. So in the second graph, we can see that the slope is increasing in nature. The slope is increasing in nature with respect to XY graph, and the magnitude of slope is also increasing with it. In the third graph, where we can see the decreasing nature of the slope, the magnitude of the slope is increasing. Why? Because the steeper it is becoming, the slope value is increasing in that very order. In the fourth graph, we can see that this is a straightforward condition of exponential decrease, and the slope is increasing, but the magnitude, that means the value of the position time graph, is decreasing. These are the various conditions, like there are 4 to 5 conditions, if I say, where you can observe, where you can witness an object. When an object is at rest, u is equals to 0. Initial velocity with initial position are stated to be at 0. That means the body is at rest. There is no motion observed. So when there is no motion observed, the particular position will stay unvaried with respect to time. That is the first condition. In the second condition, which can be like, if this is the first condition, this could be brought down to be the second condition, where we can see a constant increase or constant rise in terms of velocity. When the rise or the vanity of velocity is constant, we can see that in the xt graph, we are able to see a straight condition, a straight line condition, which could be y is equal to mx plus c. So in my sessions, which will be when you consider me as your tutor, we'll be considering basic mathematics, and we'll be considering all the basic kinds of graphs, starting from the straight line equation to ellipse, curve, and circle. All the relevant graphs which are necessary for the boards. Yes. And in the third case, we can see that there is x and t graph, this xt graph. In this, we are able to see a constant deceleration. This can be where velocity is negative. This is a very specific case where velocity, how the velocity can be negative. It's only in one condition, when the body is moving backwards. That means when the body is moving backwards, okay, or the net difference between the velocities, initial and final velocities between two objects or between the same object at different instant of time, are possessing different magnitude of velocity, that one is in increasing and the other is superficially increasing. That means if there is a condition where we can say, in the case of retardation, which can be said, the third one, Retardation, the case where we are observing negative velocity into function. Time t is equal to 0 to time t is equal to 3, we had a velocity of, let's say, 3 to 5 meter per second. Okay, that initially it started from 3, it went till 5. In the second case, from time t is equal to 4 seconds to time t is equal to 9 seconds, the velocity abruptly increased from 5 meter per second to 15 meter per second. In this case, we can observe the velocity change or the del V to be, the net del V to be negative. A case of retardation can be observed. Retardation, which is also known as negative acceleration. Although we have not considered acceleration by far, but as this comes as a topic, we are considering negative acceleration to be the retardation. Yeah. So, which also means that when we have, this is the same kind of graph which can be observed when there is no change in acceleration, or there can be a change in acceleration which is in negative. We can observe retardation into play. In this process, where velocity is positive and acceleration is negative, it is coming from straight from the thought of rectangular parabola. And yeah, it is increasing and then on a constant slope, it is aligning its values of velocity. Also, I would like to say one thing here, that this kind of graph can be observed in terms of negative acceleration. And in acceleration, we'd never have velocity to be the constant. Okay? Velocity is always changing, because if velocity is not changing, there is no acceleration observed. So I would like to very clearly specify that this same kind of a graph can be seen in terms of negative acceleration. Not in this graph. There is no acceleration in this graph. This is constant velocity, whether increasing or decreasing. But when it is constant, there is no acceleration occurring. Yeah. Moving on. Moving on to one of the concept maps which can be very predominantly deducted from the observations of changes in position, changes in velocity, and changes in time, acceleration. Yeah, with respect to time. Time being the variable. Area of xt graph, or we can say that the area which can be witnessed in terms of xt graph can give you x. Okay. And area of VT graph, like from V, we can start and we can come over X. Yes, sorry. We can start from here. Yeah. So from velocity, how to reach on X, that is position. From V, V is the variable which is reducing. Here V V, X, and A. Velocity, position, acceleration. These three are the variables which will be used respectively. X is the position, V is the velocity, and A is the acceleration. Okay. So how can one get, and then one more thing which you should know. What is the meaning of differentiation? It's basically division. And what is the meaning of integration? It's basically addition. When we are considering integration to be the addition, it is the addition of the minutest element which can be brought into scene x dx or x dA or x dl with respect to time, with respect to, say, mass or anything which are the two variables which are getting constant for that particular ratio. But integration means addition and differentiation can be termed as subtraction or division, yes, of things. Then the concept map becomes clear. So when we want to get position from velocity, we are completely adding every element which comes in terms of VDT. So we are adding it to a limit from zero, say from zero to infinity, or from zero to a time which is t is equal to 3 seconds. In that manner, we are adding up and we are getting x. In the very same manner, if we want to get velocity from acceleration, again, integration of VDT will be occurring. So this kind of a corollary could be drawn when we are witnessing all the very changes in our upcoming sessions. But this concept map is a hack for all the board aspirants. Yes. And then if we want to go the reverse manner, like this is the reverse map which is occurring. So if we were adding in the upward section of the map, in the downward section, we will be subtracting or we will be dividing. Differentiation would be occurring. So instantaneous velocity is equals to dx by dt. What do you mean by instantaneous? Instantaneous means not over a period of time, but for that particular second. Like for V, at t is equal to 1 second or t is equal to 2 seconds. Not from 1 to 2 seconds. And not from 1 to 2 seconds. No. This is known as the period. This is known as the velocity in general when we are asking. When we are calling for instantaneous velocity, we want it for that particular instant. So instantaneous velocity is equal to dx by dt. It's a very famous formula, can be deduced in our upcoming sessions. And A instantaneous is also equal to dv by dt. So there is a correlation. Correlation between x, correlation between V and A. These three will rule the kinematics. I hope you all understood the topic. Keep practicing, students, and I'll see you next time. If you have any doubts, please contact my Urban Pro profile. Thank you so much.